Example 3. This is a real-life oligopoly, a duopoly. There are two firms that control about 95% of the market in daily fantasy sports. You may have heard of these companies, DraftKings and FanDuel. If you're not familiar, daily fantasy sports works like this. Gamblers can select real-life players to be on their DraftKings fantasy team, and the better those players do, the more points they'll earn, and you can win real money. This is a legal form of gambling in the United States and in Georgia, and there's not many, so these firms have made a lot of profits in the recent years. So this is their decisions they can make. They're trying to decide whether or not they want to do advertisements. They could run advertisements on TV, or they could choose to not run advertisements on TV, okay? And you can see that this would make sense, and this would be a good time to use game theory, because if one firm advertises, that affects both firms, right? That makes sense. If DraftKings advertises a lot, you could expect that would probably adversely affect FanDuel. So these firms are deciding what they're going to do, and let's assume that these numbers here represent their profits for the year, okay? So what you're going to do whenever you see one of these examples is you're going to try to figure out what's going to happen. So I'll give you something like this on the quiz, and I'll say, is there a dominant strategy for DraftKings? Is there a dominant strategy for FanDuel? If these two compete, what do we think is going to happen? Those are the types of questions you're going to ask yourself. And usually the first thing you want to do is start with the question, are there dominant strategies? Okay, so let's figure that out. So let's start with DraftKings. Okay? DraftKings does not know what FanDuel is going to do. It takes a while to make advertisement. It takes a while for those advertisements to come on TV. So they're operating under uncertainty. You know, they could be making commercials right now, but they don't know if the other firm will have commercials that are competing with them. Okay? So let's think about it. FanDuel could advertise. So if FanDuel chooses to advertise, DraftKings could earn $40 million by advertising, or $20 million by not advertising. So if FanDuel advertises, DraftKings should advertise. Okay? Now if FanDuel doesn't advertise, DraftKings could earn $60 million by advertising, or $50 million by not advertising. So it turns out for DraftKings, they have a dominant strategy. Yes. All right? Are there dominant strategies for DraftKings? Yes. Advertise. So that is what they're going to do. What makes it a dominant strategy is, regardless of what the other firm does, that is what they're going to do. Okay? So it's a correct strategy, and they don't really have to think about what their opponent is doing. All right? Now let's think about it from FanDuel's perspective here. Okay? You've got to think about it this way now. DraftKings could advertise. If DraftKings advertises, FanDuel should not advertise. Okay? And if DraftKings doesn't advertise, then FanDuel should advertise. Okay? So, again, what we're seeing here is FanDuel's decision is uncertain. They have no dominant strategy, so we don't know what they're going to do. Okay? So, here's the deal. If this decision only happens once, this is called a one-shot game. The outcome is this. DraftKings will advertise, and FanDuel's choice is uncertain. So we actually don't know what would happen. When I use that term one-shot game, what I mean by that is if this game only gets played once. Some games get played a lot, some games only get played once, okay? So in this scenario, imagine that there is some new, let's say the Super Bowl is coming up, and we don't know if they're going to advertise or not. It's a one-shot game because the Super Bowl only comes up one time a year. In that scenario, we don't really know what's going to happen except that DraftKings would advertise. Now let's think about what would happen over time. Okay? We know that DraftKings is going to advertise. All right? So these choices are eventually going to become irrelevant. So if we have a game that has multiple iterations where they play the game many times, this is sometimes called a multi-shot game. where basically FanDuel is going to learn. All right? So let's imagine now that we're talking about the choice of advertising every day. Okay? The very first day that they begin their little oligopoly, the very first day, DraftKings advertises. FanDuel, who knows what they do, all right? Because they don't have a dominant strategy, so we don't know what the outcome is going to be. But if every single day DraftKings is advertising, well, FanDuel will eventually figure out that they shouldn't advertise. Okay? So this outcome here in this quadrant becomes the expected outcome. All right, so in a multi-shot game, there is no competitive equilibrium. But there is an outcome that will eventually occur. Talking to the other economists about this, there's not really a name for this. There's not really a name for this scenario here where there's not a competitive equilibrium. A competitive equilibrium means they both have a dominant strategy. Well, in this case, they don't. But FanDuel's strategy eventually reveals itself because it knows what DraftKings would do. So in this scenario here, what I might ask you is, if they play this game one time, what do we expect is going to happen? Right? Correct answer is DraftKings will advertise, and we don't know what FanDuel is going to do. If I ask you, if they play this game 100 times, what do you think is going to happen? Well, if they play it 100 times, DraftKings will advertise, and FanDuel will realize that they shouldn't advertise, so they won't. So that's the outcome that happens. This result is kind of hard to see without game theory, and in this case, we're just talking about two firms. You can add a third, fourth, fifth firm to this, and it can get really complicated. Basically, the size of this matrix can get larger and larger, where the choices get more and more complicated. Okay? So that's example 3. Let's now move on to example 4. And this is the very, very famous game theory example. I bet most of you have actually heard of this scenario. Something that gets brought up, popular press a lot, and if you're a business owner, it's something that you probably would need to think about if you're like operating in a small town, because oligopolies are real common, especially in smaller towns. So let's imagine that we have two villains that are deciding whether to commit to a crime. Whether to confess to a crime. Okay? So let's imagine that there are two people that basically committed a really bad crime. In fact, they killed somebody. Okay? And they're trying to decide, should they confess about it? This is a tough choice. Okay? You might be thinking, well, this is not a very interesting example. Either you confess or don't. Here's the deal, though. When you have two people that commit a crime, if one confesses and the other one doesn't, the one who doesn't confess usually receives a harsher penalty. Okay? So if you're one of these two people, let's say that this is, let's made up some names, Charlie and Brutus, and you're deciding what to do, you can either confess or don't. Here's the problem, all right? If you confess that you did the crime, that will be a good outcome if the cops know that the crime was committed at all. All right? If you both don't confess, what if you both don't confess to the crime? That might be a good outcome. If you both don't confess to the crime, they may not be able to charge you with the crime of murder. Okay? So this is going to be a complicated choice. You're locked in your jail cell, and you know the other person's locked in their jail cell, and the cops walk in and they say, look, we think you did this. And here's the deal. If you don't confess to this crime, we're going to punish you more. So do you confess or not? All right? It's a tough choice. Let's think about what the punishments might look like. So I'm going to show it for Brutus and Charlie. Notice the top one I always set up so it corresponds to the person at the top here. And so in this case, what I'm going to be showing is the amount of years they will spend in prison if they confess, don't confess, etc. All right? So I'm going to put in some values here. In this case, low numbers are good numbers. Low numbers are good because that means less time in jail. So let's think about their strategies here, okay? Basically what's going on here is, ideally what you would like to occur is you would want to confess and the other one not confess, okay? So the cop comes into your jail cell and they say, look, if you confess to this crime, we'll let you off easy. We just want to know if that other person was in on it. We want to punish them, okay? So did you commit the crime or not? Ideally, you would like to confess and the other person not confess. Problem is you don't control their choice. Okay, so let's think about the scenario here. Let's start with Charlie. We need to figure out if there are dominant strategies. So let's start with Charlie. Okay, see if you can figure it out there. What should Charlie do? Charlie's operating under uncertainty here, meaning Charlie does not know what Brutus is going to do. So this is the steps that he would take in his head. All right? If Brutus confesses, here are my choices. If Brutus confesses, I can confess and get 5 years in prison, or I can choose not to confess and get 10 years in prison. Now, he wants to confess then. So, assuming Brutus confesses, Charlie would confess. Now let's think about the other scenario here. Let's say that Brutus doesn't confess to the crime. In this case, Charlie could confess and get 1 year, or not confess and get 2 years. So, if Brutus doesn't confess, well then Charlie would confess. So it turns out that there is a dominant strategy. Charlie wants to confess regardless of what Brutus does. All right, let's flip it around now. Let's think about Brutus. Brutus is locked away in a different jail cell. Doesn't know what's going on over there with Charlie. Okay? So Brutus is deciding what to do. If Charlie confesses, Brutus can get 5 years by confessing or 10 by not confessing. All right? So if Charlie confesses, Brutus should confess. If Charlie doesn't confess, then Brutus will get 1 year by confessing or 2 years by not confessing. So Brutus should confess. So here is the outcome. We call this a competitive equilibrium. We know what each of them are going to do. So we have a competitive equilibrium. All right? That's the definition of a competitive equilibrium, where everybody in the game has the same strategy regardless of what the other one does. So the outcome that will occur is this one. Okay? Can you see why this is an interesting scenario? Think about it here. They're both confessing, but they would both be better off if they didn't confess. So the competitive equilibrium is actually not the best outcome for either person. They would both be better off if they didn't confess. Now this is interesting though, because think about the scenario. Imagine you're Charlie and I'm Brutus, okay? And they're taking us back to our jail cells, and I grab you for a second and I'm like, hey, listen to me, don't confess, okay? I'm not going to confess, you don't confess, all right? When they start questioning you, just do not confess to this crime, and then you go back to your jail cell. Think about the problem here, all right? If they don't confess, all right, if Charlie doesn't confess and Brutus does, you're screwed. Charlie is screwed, okay? So basically they're in a scenario where they have to trust the other one. This is like setting prices for those two gas stations. If they agree to set a high price, they have to trust that the other one will stick to it. But this is going to be even harder because this is clearly a one-shot game. It's only going to happen one time. So do you trust the other person or not? Okay? This is called a prisoner's dilemma scenario. So if on the exam, if I say, is there a prisoner's dilemma scenario, what that means is there's an outcome that would make both better off relative to the competitive equilibrium. so this is what you're thinking about as you go through one of these questions. So if I just give you a table like this and I say, is this a prisoner's dilemma scenario? This is what you ask yourself. First, you ask yourself, are there dominant strategies? All right, that's the first thing that has to happen. There needs to be dominant strategies because there needs to be a competitive equilibrium. Okay, so first ask yourself, are there dominant strategies? Okay, from that, you'll figure out, is there a competitive equilibrium? Okay, and in fact, if they both have dominant strategies, then there will indeed be a competitive equilibrium. And then lastly, ask yourself, could they both be made better off? That's the key. They both have to be made better off. If just one of them could be better off, that doesn't matter, right? If just Brutus can do better, that doesn't really matter because Charlie needs an incentive to change too. Okay? So then ask yourself, could they both be made better off? And if the answer is yes, if there is a dominant strategy for both, if there's a competitive equilibrium, but then you can still make both better off, then you have a prisoner's dilemma scenario. And in this case, we indeed do. And you can imagine why this is a problem, right? There are things that would change the outcome. If they could both spend a day together talking about their strategies, they might reach this outcome. If they were both in the same room together, I'm sure they'd be able to reach this outcome, right? But the problem is they're going to separate them, take them to their jail cells, not give them any time to communicate to one another, and then you don't know what's going to happen. Because if you're Charlie, you don't know what Brutus is going to do, and vice versa, okay? So prisoner's dilemma scenarios are actually really common, okay? Trying to decide, should a bar set a happy hour? Well, they need to think about their competitors. Trying to decide how to set prices. Trying to decide whether or not to advertise. A lot of the time, by both competing, they end up with an outcome that's not best for either party, okay? And again, this is called a prisoner's dilemma scenario.